Welcome back my dear friends, a very good morning, good afternoon and good evening to all of you wherever you are in this part of the globe. And as you know, this is the DADM 3, which is Data Analysis and Decision Making 3 course under the NPTEL MOOC series. And as this course I give a just general outline of the course, not a syllabus or the what is you are going to teach, but this course is, as you all know, is basically for 12 weeks, 60 lectures, 30 contact hours. Each week we have 5 lectures, and after the 5 lectures you have that assignment. One assignment is already to be solved. By the time you are reading this, you are listening to this, you have already solved assignment 1. And in totality we will have 12 assignments and then the question answer for the final examination. So, if you remember, we were discussing about utility, the 4 different utility functions. Obviously, there are others also. I did not go into the details about that. We discussed about absolute risk aversion, relative risk aversion, how they are derived conceptually. Then I also mentioned that how these two this absolute and relative risk aversion properties can be utilized to find out what type of properties the utility functions have. That was from the theoretical point of view. Then practically considering a hypothetical example, we drew and using very simple Excel sheet the values of a prime, r prime, and before that you had to find out u prime and u double prime. And based on that we saw that the results which we are getting theoretically can also be obtained practically when you are using the Excel sheet. And then we considered about the certainty value, what is the concept of certainty value, how certainty value can be utilized to rank different decisions. And the certainty value will definitely depend on the utility function or other parameters. If they will change for the same human being, if the utility function changes, the certainty value also changes depending on the situation which you have. So, each gamble will have a certainty value even if the utility function is same. So, the gamble changes whether corresponding the probability or the net value output. So, that will have a consequence on the UW value, and that would basically have an effect on the expected value of the gamble, which will basically have a bearing on trying to find out the certainty value for which the person would be indifferent technically if a rational decision is to be taken. But obviously, human beings decision makers can either love the gamble or be indifferent between the gamble and the certainty value, or basically take the certainty value and avoid the gamble. So, we will classify human beings as risk lovers, risk indifferent person and risk haters. So, with this we will start the 8th lecture, which is in the second week, which is the 3rd lecture in the second week, and we will try to basically give some a very simplistic outline that how you can analyze using very simple pictorial diagram about the values of u prime, and also get some information on the value of a prime without being aware of the utility function. So, this is a very simple thought out experiment. It may be simple, and my way of explanation would I will try to stick it as make it as simple as possible, and then why it is being utilized, all these things will come up as we discuss the optimization concepts. So, consider you draw a 2-dimensional graph. So, on a Cartesian coordinate on a graph paper, along the y axis you have the values of c. So, c is basically the certainty value. So, how you mark it I am going to come to that later, and along the x axis you mark the different values of the wealth. So, here I have taken, as you can see, these values are a, b. So, they will keep changing. And what you do is that you basically draw a 45 degrees line, which is the blue one. So, I will not mark it, but just show it here. So, this is the 45 degrees line, it goes, and you mark any two values of a and b on the x axis. Now, consider a is the total wealth and or the total so called the output based wealth. What is that? I am going to come to that later. Consider that is the output only, do not consider the wealth for the simple case, and even if it is a wealth, I will give you a simple idea that how it can be converted into the overall utility based on the wealth. Now, consider you are tossing a coin that is the gamble, and it is an unbiased coin, probabilities are half and half. Now, moreover consider that your utility is a simple linear function, that means u w is equal to w. So, A is the wealth, so the utility function will be u of A, which is again A. In the other case, if B is the wealth, utility is again u w, so that the utility based on the value of B is B. Now, consider when you play the gamble, the probability of getting in A is half, probability of getting a B is half. So, if I want to find out the expected value, it will be A into half plus B into half, which would be, now I will mark, would be a midpoint between A and B. So, A plus B by half. Now, take a vertical up from here, it touches the line 45 degrees. Now, go horizontally onto the left. So, consider this value as C1. Now, what you do is that in practicality you place on one table a value of C1 and no other values, which is a certainty case, and on the other table you place the values of A and B. Now, that means you say that if you toss a coin, the probability comes half, you get a head comes, you get A, and if on a tail comes, you get B. Now, you ask the person which one would he or she take. Now, consider the person, technically it would mean that if the person is indifferent between this C1 or the other gamble, which is A and B, which means the certainty value for this person is such that it exactly matches to C1, which basically would give you a hint that the utility function which the person is utilizing to arrive that answer is a linear one, as we have discussed. Now, consider the other two cases. In case 1, the person says that the value of C1 which is given to him or her to take with respect to the gamble A and B, he or she wants to take a higher value such that he or she is different between that higher value, which is C2 considered, with respect to the expected value of A and B. So, if that is the case, then obviously you would mean that the utility function is such that for as you keep changing A and B without changing the probability and half, you will get different values of so called C2s, which would technically would be marked on the upper portion of the graph, which is above the blue line in this area. I am not going to mark it, it will become too cluttered. So, it will be marked here. Now, in the other case, consider the person says that no, he or she would basically go for a lower value in the case sense that the expected value of the gamble, which is A plus B by 2, that's actual certainty value is less than C1. So, that consider that those sets are, as you change the values on A and B, they are C3. So, obviously, in that case this part of the portion of the graph would be lower than which I have shown in the green line. Technically, it would mean that as you are able to plot it, you will have one set of graphs which is above the 45 degrees line, which is the blue one, and another set of graphs would be below the 45 degrees line, which is the blue one again. Now, if you can think about the utility function which you have discussed, based on which we found out that we came with the conclusion with the non-Hessian property that u prime would be greater than 0, but the value of u double prime would be greater than 0, equal to 0 or less than 0, depending on what type of property the human being has, whether he wants to take a risk, will be indifferent with respect to risk, or basically try to avoid the risk. So, the sets of graph properties of convex and concavity, you will have one sets of graph, let me use a different color, sorry. So, sets of graphs which are here and the sets of graphs which are here, they would basically portray two different concepts. In one case where the person is risk averse, in another case the person is basically risk lover. So, in one case you want to avoid, and another case you want to take that risk. And the 45 degrees line would basically mean that using the utility function to be very simple linear, that means u w is equal to w, you will basically be able to plot all the values of C1 such that C1 is equal to A plus B by 2. So, in this way you are able to characterize what type of utility function the human being has without going into the details of the utility function as such. So, let me explain. So, whatever I have said I am going to basically now explain that with the PPT slide. So, A and B are the wealth values, that is the values of W, which is the wealth. Also for ease of analysis we consider the utility function to be W. So, now this 45 degrees line was done as an experiment. It can be different graphs or curves depending on what type of utility function you are using, such that the value expected value of A and B exactly matches the expected value of the certainty value depending on the utility function. You form a lottery such that there is an outcome of A with probability P and an outcome B with probability 1 minus P. So, now here I said that the probabilities are half and half. That means, what we are doing considering is that we are considering that the P and 1 minus P are both half. Change the values of P. So, it can be done, but for our case we did not consider it in this thought out experiment. Whatever I told, I consider only changing A and B. But still let me read it. So, change the values of P and ask the investor how much certain wealth or C he or she will have in place of the lottery. Hence, the value of C will keep changing with the probability value, but here we are not changing the value of P and 1 minus P, we are only changing the values of A and B. Now, the expected value of the lottery would be what we know, this P into A plus 1 minus P into B, which is basically if P and 1 minus P are half and half, it will be A plus B by 2. A risk averse person will basically have a certainty value which is less than this expected value of the gamble, and we will plot the values of C, and you have already have the expected value of the lottery. Based on that, you can basically compare that whether C is greater, whether it is in the subset C2 or in the subset C3, such that you can basically classify what type of the utility function that person has. Now, the next question we will try to basically tackle is that how would you find the explicit form of the utility function of a person. Suppose you know that it is of the form uw is equal to the exponential function, which is minus a e to the power minus aw. So, you will keep asking the person. So, you know his her utility function, but you do not know the parameters a which you have to find out. So, you ask the person that you are given a lottery which has a 50-50 chance, which is P is equal to half, Q is equal to half of winning. In one case it is basically 10 lakhs and another case is basically 4 lakhs. So, I will win 10 lakhs with the probability half, I will win basically 4 lakhs with probability half. So, in order to buy this lottery, what is he or she willing to basically pay? Now, in that case, if the lottery basically has a utility function which is linear, then obviously the expected value which is 10 lakhs plus 4 lakhs divided by 2, which would basically be a linear line, will be utilized to find out the value of C for the certainty value for that person. So, based on that we will proceed. So, let us continue reading it. So, in order to buy this lottery, what he or she will be willing to pay is basically the main question. Suppose the answer is, say for example, 5 lakhs. Then it means the person is indifferent between a certainty value amount 5 lakhs and the lottery, which is basically a fair gamble. So, in that case the person is indifferent, and based on that you can take a decision that what the actual person is thinking about the certainty value. So, once you equate that, you will basically have that 5 lakhs which came out to be the certainty value based on which you are indifferent. So, in the left hand side, this 1 would basically mean the probability for the certainty value, and this function which I am just hovering in the pen is basically the utility function based on the value that the certainty value is being utilized. So, certainty value, as I said, is 5 lakhs. So, that would be equated to the expected value of the gamble, where 0.5 are the heads and tails, and the corresponding utilities for 10 lakhs is given by, where again hovering my pointer, and the second case would be, as pointed out, is basically the utility function based on the fact when 4 lakhs comes out to be the value. So, solving through iteration process, we can find out the value of A and then proceed to give some semblance of what type of utility function that human being has. So, an investor can always say whether A and B. So, for an investor I can categorize, that means I can say A is better than B in the sense that I am getting more benefit. In other sense we can say A is equal to B, such the benefits are equal. In another case, you can say that A is less than B. So, here we can rank them, and this ranking would basically depend on the util function or the ranking system we are trying to utilize. Now, consider x and y are equal, then suppose combine x with another decision z such that x has a probability of p, and the probability for z is basically 1 minus p. So, in one case you would basically consider x, and in another case you consider z. On the same lines, we have the same decision z with y also, such that y is with probability p and z is again is basically probability 1 minus p. So, once I try to find out the expected value for the corresponding to the decision x, and when I basically try to find out the expected value corresponding to the value of y, considering z has been added in both the cases. So, this will give us some idea about the equivalence between x and y. So, for every gamble there is a certainty equivalence such that the person is indifferent between the gamble and the certainty value, based on which he or she will take a decisions accordingly. Now, we will consider the comparison between mean variance and the utility theory. So, the mean variance we will try to solve the problem from the optimization point of view from the finance. So, that the mean variance theory is utilized. So, the utility function and the mean variance theorem. So, the utility function based on the fact if it is quadratic. So, we will basically have 3 assets and the prices are as follows. So, this serial number gives you different instances or the examples. So, the values of this value of asset A is 100, 110, 150, 120, 125, which is basically the second column. I am just marking it out, showing with a pointer, while the corresponding values for the other 2 assets B and C are given in the third and the fourth column. Now, what we need to find out are the returns. So, we will consider the absolute returns, which will be for A would be 110 minus 100 by 100. Similarly, for the next case it would be 115 for A only, it will be 115 minus 110 by 100, and based on that fact you find out the returns for the investment A. Similarly, you find out the returns for investment B and C accordingly. So, consider the probabilities are given for all these occurrences. So, serial number which you have got is basically corresponding to the occurrences, nothing to do with the, say for example, the utilities. So, occurrences would basically lead to the fact that how you are able to find out the probability. So, in this case I would need to find out the average return. So, R bar A is 1.06, R bar B is 1.05, R bar C is 1.14. So, in this case the values of standard deviation for A, B, C would be given as 25 into 10 to the power minus 3 for A, 22 into 10 to the power minus 3 for B, and 52 into 10 to the power minus 3 for C. And we will also consider the weights or the so called amount of investment which is happening on an average for A, B, C would be given by 114, 119, 110. Now, if less risk interest, so if a less risk interest in terms of the total returns is 0.5, then using the mean variance theorem we will rank them. So, the ranking would be based on the fact that you are using the standard normal deviate. So, it will be R A minus R F divided by sigma A for the first case. Similarly, for the second case it would be R B minus R F divided by sigma B, and the third case would be R C minus R F divided by sigma C. Now, remember one thing. So, once you do that, you are basically converting them into the standard normal deviate. So, that is the reason. So, using quadratic utility function, which is quadratic in nature, which is W minus B W square, with B is equal to minus 0.002, we can rank this system. So, what we do is that we find out the values of the standard normal deviate, and in this case these values are coming out to be, as I mentioned, it would be coming out to be 25 for B, 22.4 for A, and 12.3 for C. So, if you rank them, B basically would come out the best. Similarly, you will basically have A and C coming out later on. Now consider the following example with two different sets of outcomes. Again as the utility function is quadratic, but in this case I basically consider the outcomes are given, and for scenario 1, scenario 2. So, scenario 1 outcomes are, I am just reading the main first column, it is 15, 20, 25, 10, 5, and for outcomes scenarios for scenario 2 would be 20, 12, 25, 17, 8 and 30. So, the utilities again I consider very arbitrarily to be 1.52, 2.53, 3.54, and the corresponding utilities found out using the quadratic utility function. And also we find out the probability based on the fact that both the scenarios need to be counted together, such that the total of all the scenarios is 212. So, accordingly we have to calculate the expected utility function and basically try to find out such that this utility function, as it keep changing, you will basically have a different expected value, and once the expected value is found out, you can basically throw some light on the certainty value also, and obviously it will give you some idea what type of person he or she is. So, this is a very simple diagram. We have the deterministic versus probabilistic on the left hand side. So, both are probabilistic, but what you are trying to do is that you are trying to basically combine and find out the expected value on the left hand side. So, for this the expected value would be P 1 into W 1 plus P 2 into W 2 plus P 3 into W 3 plus P 4 into W 4. Now, mark it here, W 1, W 2, W 3, W 4 are technically the utilities. So, if I want to go into detail and I consider the utility functions to be U W, so obviously for the left hand side I will use the summation for all I P I U of W I. So, here W 1, W 2, W 3 are basically the corresponding wealth. Similarly, when I find out on the right hand side and consider the probability, obviously they would be same. This is P 1, P 2, P 3, P 4. So, I want to find out the expected value. So, I have to basically break them up. So, what I mean is that first find out the utility of this arm. So, that will be H 1 into U of B 1 plus 1 minus H 1 into 0. Similarly, for the second one will be H 2 into B 2 U of B 2 plus 1 minus H 2 into U of 0. So, based on that we find out the expected value for each the binomial so called output which you are getting. So, now if the whole thing has to be balanced, then the expected value which is P 1 into the expected value of the yellow circled line plus P 2 into the expected value on the second arm, similarly P 3 into expected value of the third arm, so on and so forth. When you add them up, should be exactly equal to the expected value which you have on the left hand side. So, based on that you can basically expand it or contract it such that you are expanding means make more arms such that you are able to understand how the utility function can be managed to find out the certainty value and the expected value. Now, we will consider some other criteria for investment projects and portfolio decisions, and this I will come up later on in the optimization framework. So, you have the geometric mean concept, you have the safety first criteria. Safety first criteria is basically important to understand. You have the stochastic dominance and the analysis in terms of characteristics of the return distribution. So, let us consider the geometric one. So, if you have read all these things, I am sure you have read. So, the central tendency is given by different formulas. So, one is the mean, arithmetic mean, one is the geometric mean, one is the harmonic mean. So, you are talking about the geometric mean. So, it will give you basically the highest probability of reaching or exceeding any given wealth level in the shortest possible time, and is the highest probability of exceeding any given wealth level over any given period of time. So, basically it will be geometric mean would give you this information such that you take the highest probability and utilize it to find out the when it will be when would be the given wealth level be achieved in the shortest possible time, and the highest probability of exceeding and any given wealth level over any given period of time would basically be given by the geometric mean. So, how does the geometric mean work? So, you basically find out Rij, which is the ith possible rating for the jth portfolio. So, I have basically different returns in in a basket for the jth portfolio. So, J1, J2, J3, J4 till say for example J10, and each of them would basically have say for example I is equal to 1 to n number of such decisions. So, if I want to find out the overall expected value, I need to find out basically the overall geometric mean, and such that the geometric mean will basically give me the ranking of the utilities. So, the average value of the geometric mean for the jth portfolio is the baskets. So, it will be 1 plus r1 r suffix 1 comma j, and that would basically be put to the power of Pij. So, Pij is basically the probability, while Rij is basically the return which you, or the so called output which you are getting from the first decision, and you will basically be multiplying each and every term where the suffix would be the probabilities, and to the number or the values to which you are changing that power would basically be the corresponding returns of the decisions. Now, remember one thing, geometric mean can also be formulated based on the fact you are utilizing the concept of returns, where small r is equal to P2 minus P1 divided by P1. So, what is P1 and P2? Remember that. So, is basically the P2 is basically the so called returns coming out from the second day, and while P1 is basically investment which is happening. So, I want to find out the returns on a ratios on a percentage scale. So, consider with the following combination assets A, B and C in the following ratios. So, these are the weights. The corresponding returns are given, and these are for A, it is 0.2, 1/3, 0.25 in the first, second, third decision. For B, it is 0.2, 1/3, 0.25 in the first, second, third decision. Similarly, for C, it is 0.6, 1/3 and 0.5 for the third decision. So, if I want to find out the return using the geometric mean for the portfolio based on 1. So, it will be basically, so these 10, 20, 30 are given as the returns respectively. So, what I want to do is that 1 plus the returns to the power. So, basically I multiply 1 plus 0.1 to the power 0 to the power 0.2. So, I keep it doing it, and obviously minus 1 because it is the returns formulas are given. One is R is equal to P2 minus P1 by P1. So, these P1, P2 are not the prices. Similarly, capital R would be equal to P2 by P1. So, that is why this minus 1 is coming here. So, based on that we find out is 23.7, 19.7, 22.2, and hence we will rank the decision 1. So, with this I will end this 8th lecture and continue discussing more about utility and how they can be utilized for the optimization problem. Have a nice day and thank you very much.